Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone, today we have with us Siva Shakti, who is a PhD candidate at the Indian Institute of Science, Education and Research in Trivandrum, which is in the south of India. Hi Siva, thank you for taking the time to speak with us.
Oh, thank you so much for having me, and it's a real pleasure to be a part of Real Scientists. Thank you.
Wonderful. All right, let's begin. Let's start by understanding your research. So could you explain your research in super simple words to us?
Super simple, it's fine. Let me try. I work in the area of microwave photonics. That is, light extends across an entire spectrum, right?
Mm-hmm.
So there are different frequencies, like you have gamma rays, you have visible rays, you have infrared, and then you have microwave radiation, right? But processing certain wavelengths or dealing with certain wavelengths or frequencies are much harder than certain other frequencies. Okay, for example, processing microwave signals are harder than processing optical signals. By optical signals, I specifically mean infrared signals. Okay, like a wavelength around 1500 nanometer. So what we do is we basically take information from the microwave regime and we transfer it to the optical regime, that is to the mid-infrared regime, and then we process it over there. Okay, after processing, we again do something called as demodulation. So the process of taking the signal from the microwave regime to the optical regime is called modulation, and then you process it over there. And after processing it, and if you want to take some information out of it, you take it and then you bring it back to the microwave regime, and that's called demodulation.
Right.
So I work on this, and I basically don't exactly work in nanoscience or material science. I do what are called as proof of concept experiments. Okay, for example, if you want to come up with a device that would detect a microwave frequency, I'll be coming up with a concept like some concept which is based on a nonlinear photonic technique, and then I'll see if the processing can be done with this nonlinear photonic technique. And then this is generally done with tabletop setups. Okay, using kilometers of optical fibers. For example, if you come to my lab will be, like so cumbersome. It's like filled with kilometers of optical fibers.
Wow.
Okay, and then what you do is the result is that you've got, once the principle is ready, you want to create a device. But when you want to create a device, you really don't want these tabletop setups. Right, because these devices are generally used for optical communication or electronic warfare. In those areas, you really don't want to carry these big tabletop setups, right? So what you do is you go for the nanoscale regime. So that's when nanoscale comes into the picture. So that's pretty much about my research.
Aha, okay, that sounds super interesting. Wonderful. So what can the followers expect? What can the Real Sci_Nano Twitter account follower expect in the week that you will be curating?
Oh, I'm happy to be curating next week because the last time I curated, it was completely about optics. That was like an altogether a different regime. I just talked about optics and colors and all those things. But this week we'll be looking into nano optics. So on Monday we'll be talking about how the field of nano photonics emerged, right? How nano waveguides are being prepared, or how different resonators are being prepared. And on Tuesday, we'll be talking about the role of whispering gallery. I'll be talking about what are whispering galleries. You must have known that in galleries, people can hear whispers when one person talks from one corner, a person standing across the dome can hear the whisper. So such domes are called whispering gallery domes. Right. But certain things are also, such things are also present in optics. So we'll be talking about that. On Wednesday, we'll be talking about biosensing, which is one of the most important applications of nanophotonics. And on Thursday, we'll be talking about the telecommunication sector. Like I said, right now the telecommunication happens at 1500 nanometer, but you know that the population is increasing. We want more and more and more, so we are definitely facing a big crunch.
Right.
So are we really facing a crunch? If we are really facing a crunch, we need to see what other wavelength can be used for, increasing the bandwidth. So
Right.
we'll be talking about that on Thursday, and on Friday some other interesting nanophotonic effects. I'm not going to tell about that because, well, one, it's difficult to shot and tell without some pictures, so I'm not going to tell that.
Right.
But it'll be some colorful effects. And on
Looking forward
Saturday
to
we'll
that.
talk about the future of nanophotonics, like what I think, where nanophotonics will go, or what is the next stage of nanophotonics, and so on. Yeah.
Okay,
So
wonderful. That sounds wonderful. Well, we are looking forward to your time on Real Scientist Girl Nano. Thank you very much for speaking to us, Siva. Thank you.
thank you so much for having me.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.